Welcome to the Deep Dive. Today we're going to be taking a deep dive into AI, artificial intelligence. You guys have sent us a ton of articles and research, and it seems like you're really interested in the different types of AI, what they can do, and how they actually work. So we're so excited to unpack all of this with you.
Yeah, it is incredible to see how far AI has already come. We've gone from these basic algorithms to systems that can almost, think like humans, and the potential is just mind-blowing.
Right, and we're not just talking about some far-off future. We're already using AI every single day. Think about those eerily accurate Netflix recommendations. I mean, that's AI working right there, but there's so much more to it.
Absolutely. So at its core, artificial intelligence is all about, machines learning from data to perform tasks that would usually require, human intelligence. There are a bunch of different ways that AI can actually learn depending on, what we want it to do.
Okay, so let's break it down. Starting with the different types of AI based on what they can actually do. We've got narrow AI, general AI, and the kind of intimidating superintelligent AI.
Yeah, that's a good way to categorize them.
Mhm.
So narrow AI, you might also hear it called weak AI. This is the type we see most often today. It's designed to be a master of one specific task.
So that's like Siri being able to understand my questions, but not being able to bake a cake yet.
Exactly.
Yeah.
It's really great at what it's trained for, but its abilities are limited to that specific domain. So other examples that you probably encounter all the time are, facial recognition when you unlock your phone spam filter, saving you from a mountain of junk email and those chatbots that pop up on websites.
Got it. So narrow AI is like a specialist?
Yeah.
But what about general AI?
Yeah.
This is where things get a bit more like sci-fi, right?
Yeah, general AI or strong AI, this is where we're talking about AI that has a much wider range of cognitive abilities. It's about an AI that could, learn and solve problems across different areas just like a human can.
So that's like the AI we see in movies,
Yeah.
like holding conversations or maybe even composing symphonies.
Yeah, that's the idea. It's about, AI being able to understand complex concepts, adapt to new situations, and potentially even have some level of consciousness.
Whoa. But we're a long way from that.
Right, indeed. We're still trying to figure out exactly how to get there. It's a huge challenge, especially because it requires AI to grasp things like consciousness and common sense reasoning, which even neuroscientists are still unraveling.
So general AI is like the holy grail of AI research,
Yeah.
but not something we're going to be seeing tomorrow. What about this super intelligent AI? Is that even a real possibility?
So superintelligent AI, or ASI for short, this is where AI theoretically surpasses human intelligence in every aspect. It's fascinating to think about, but also raises a ton of ethical questions.
Yeah, what happens when we create something that's smarter than us in every way?
It's a big question with no easy answers, but it's really important to remember that ASI is still purely hypothetical. We haven't even achieved general AI yet, so superintelligent AI is even further down the line.
Okay, so that's AI categorized by what it can do.
Yeah.
What about those different functionalities you mentioned? How an AI interacts with the world seems like a whole other layer to this.
Right. Another way to classify AI is by how it functions. Your source material dives into 4 categories here: reactive machines, limited memory theory of mind, and self-aware AI.
All right, let's start with reactive machines. What makes them tick?
So reactive machines are the simplest form of AI. They can analyze a situation and respond, but they don't have any memory of past experiences. They operate purely on instinct, you could say.
So they're reacting to the present moment, but they don't learn from what's happened before.
Exactly. Think about IBM's Deep Blue, the chess-playing computer that famously beat Garry Kasparov. That's a prime example of a reactive machine.
Ah, Deep Blue. That was a landmark event. So it could analyze the chessboard and make moves, but it wasn't remembering past games or Kasparov's strategies.
Precisely. It was making decisions based on the immediate situation, not on any stored knowledge or past experience.
Fascinating. Okay, so reactive machines are all about the here and now. How is limited memory AI different?
So limited memory AI systems are a step up because they can actually use past data to improve their decisions. Think of it like they have a short-term memory.
So they can learn from their experiences, but only up to a point.
Exactly. A great example is self-driving cars. They use sensors to collect data about their surroundings and make decisions in real time, but they also draw on data from past experiences, things like previous routes or traffic patterns, to enhance their navigation skills.
That makes sense. They're not just reacting to the car in front of them, but also using their memory of past traffic jams to choose a better route.
Right. And we see this type of AI in other areas as well, like chatbots, for instance, can remember your previous interactions to provide more personalized responses. They're learning from your conversation history, but that memory is limited to a certain scope.
All right, so limited memory AI, builds on those reactive machines.
Yeah.
What about this theory of mind AI? That sounds pretty advanced.
It is. Theory of mind AI is still very much in development, but it's a really fascinating area of research. This type of AI aims to understand emotions, beliefs, and needs both in humans and potentially in other AI systems.
Whoa, so it's like AI that can read minds? That's getting into some serious sci-fi territory.
It is quite futuristic, but it's also a field with active research. Imagine AI that could understand your intentions and emotions, allowing it to interact with you on a much deeper level. That's the goal.
It's a fascinating concept, but also a bit unsettling. Imagine a machine knowing what you're thinking before you even say it. What about self-aware AI? Is that even on the radar?
Self-aware AI is the most futuristic and hypothetical of them all. This would be about machines that are conscious and self-aware, similar to humans.
So machines aware of their own existence, with thoughts and feelings of their own.
That's the concept. But it's important to understand that self-aware AI is purely theoretical. We were nowhere near achieving this level of AI, and there's even debate about whether it's actually possible.
Okay, that's a lot to take in. We've covered AI based on what it can do and how it functions. I'm ready for the next level.
The next level is all about how AI actually learns. It gets into the nitty-gritty of those learning models we touched on earlier. Your sources mention 4 main types: supervised learning, unsupervised learning, reinforcement learning, and deep learning.
All right, hit me with it. What's supervised learning all about?
Imagine you're teaching a child by showing them examples. That's the essence of supervised learning. We give the AI system a set of labeled data, which means the data is already categorized or tagged. From there, the AI learns to spot patterns in that data and make predictions based on those patterns.
So it's like giving the AI a stack of photos, some labeled cat and some labeled dog, and it learns to tell the difference.
You got it.
Yeah.
And the more data we feed it, the better it gets at recognizing those patterns and making accurate predictions.
Okay, that makes sense. What about unsupervised learning? How does that work?
Oh, with unsupervised learning, we don't give the AI any labels. We give it a pile of data and let it figure out the patterns and relationships on its own.
So it's like giving the AI a giant jigsaw puzzle with no picture on the box.
Perfect analogy. The AI has to analyze the data, identify similarities and differences, and group the data based on the patterns it discovers.
So it's all about finding hidden connections in the data without any guidance. What are some real-world examples of that?
One example is market segmentation. Companies use unsupervised learning algorithms to analyze customer data and group customers into different categories based on their shopping habits or demographics. This helps them target their marketing more effectively.
Interesting. So instead of telling the AI, these are the different types of customers, it figures it out on its own.
That's right. It's like the AI is a detective piecing together clues from the data to understand different customer groups.
Yeah.
Exactly. It's like the AI is a detective, piecing together clues from the data to understand these different customer groups.
Okay, so we've got supervised learning, where the AI learns from labeled examples, and then unsupervised learning, where it's all about pattern detection. What about reinforcement learning?
So reinforcement learning is all about learning through trial and error. It's just like we do in so many aspects of life. It's about creating an environment where the AI can interact and learn from the, consequences of its actions.
So like if I'm learning to ride a bike, I might wobble a bit, maybe even fall, but eventually I figure out how to balance and ride smoothly. Is that the idea?
That's a great analogy. So in reinforcement learning, the AI gets rewards for actions that lead to desired outcomes and then penalties for actions that don't. Think about AlphaGo, the AI that mastered the incredibly complex game of Go. It learned by playing millions of games against itself, getting better with each win and learning from each loss.
So it's basically like training a dog with treats and timeouts.
Mm-hmm.
Except in this case, the treat might be winning a game against a world champion.
Exactly. And this type of learning is being used in robotics as well. Robots can learn to perform these really intricate tasks, like grasping objects or navigating obstacles through this process of trial and error and feedback.
That's pretty amazing. Okay, so we've covered supervised, unsupervised, and reinforcement learning.
Yeah.
What about deep learning? I feel like that's a term that's everywhere these days.
Yeah, deep learning is a subset of machine learning that's been making waves, and for good reason. It uses artificial neural networks, which, as the name suggests, are inspired by the structure of the human brain.
So it's like we're trying to create AI that thinks the way WE do.
In a way, yes. So deep learning networks have multiple layers, and each layer processes information and passes it on to the next, allowing the system to learn these incredibly complex patterns and relationships.
Okay, that sounds pretty intense. What are some real-world examples of deep learning in action?
So deep learning is powering some of the most impressive AI applications that we see today. It's behind things like image recognition, natural language processing, and even those voice assistants that we talk to on our phones. For example, think about how Google Photos can recognize faces and objects in pictures, or how Apple's Face ID can unlock your phone just by scanning your face. That's deep learning at work.
Wow, so deep learning is really pushing the boundaries of what AI can do.
Hmm.
All incredibly fascinating, but I have to admit it's a lot to wrap my head around. We've covered so much ground already.
You're right, we have. We've gone from the basic definition of AI to different types based on capabilities and functionalities. And we've explored these amazing learning models that are really propelling AI forward.
And we even touched on the concept of superintelligent AI, which is still pretty mind-blowing to think about.
Correct.
But there's one more thing from your research that I really want to dive into, artificial general intelligence.
AGI,
Yeah.
yes. That's where it gets really interesting.
Right, we briefly mentioned it earlier, but I want to explore it further. What exactly I call this artificial general intelligence, and what would it mean for AI to have human-level intelligence?
So AGI is like the next frontier in AI. It's the idea of an AI that can perform a wide intellectual task that a human being can. Unlike narrow AI, which is specialized AGI, would be capable of learning and solving problems across a wide range of domains just like we do.
So it's like having a single AI that could write a novel, compose a symphony, A&D, solve complex equations.
Exactly. It's about AI having that same versatility and adaptability that we see in human intelligence. It wouldn't be limited to just a single area of expertise.
That's incredible. What would be the key characteristics of AGI? What would set it apart from the other types of AI we've talked about?
So one of the key characteristics of AGI would be its ability to learn across domains. It wouldn't be restricted to a specific task or subject. It could seamlessly move from learning a new language to mastering a musical instrument to solving scientific problems.
So it wouldn't be like, okay, this AI is good at math, but it can't write poetry. It would be able to do it all. That's fascinating.
Yeah.
What else would define AGI?
Another key characteristic would be its ability to reason, like a human AGI, would need to understand context, apply logic, and make decisions based on incomplete information, just as we do in the real world.
Right, wouldn't just be following a set of pre-programmed rules. It would be thinking critically, adapting to new situations, and maybe even coming up with its own creative solutions.
Absolutely. And while it might seem a bit less crucial than those other characteristics, emotional intelligence would also be important for AGI.
Emotional intelligence.
Yeah.
That's interesting. We often think of AI as being very logical and analytical, not necessarily emotional.
True. But for an AI to truly interact with us on a human level, it would need to understand and respond to human emotions.
That makes sense. It's part of what makes us human, so it would be important for AGI to navigate those nuances of human interaction. Okay, so AGI sounds incredibly advanced. What's the current state of research? Are we anywhere close to achieving this level of AI?
So AGI is still very much a goal on the horizon, but there's a lot of exciting research happening right now. One approach that's particularly fascinating is drawing inspiration from the human brain itself.
So like reverse engineering the brain to figure out how intelligence works at its core.
Exactly. Researchers are trying to understand the neural processes that underlie human cognition and intelligence. They're studying how neurons communicate, how memories are formed, and how our brains process information and make decisions.
It's like unlocking the secrets of the most complex organ in our body to build a better AI.
That's one way to think about it. And by understanding how the brain works, researchers hope to build AI systems that are more sophisticated, adaptable, and maybe even capable of some level of consciousness.
That's pretty mind-blowing. Are there any other promising approaches to AGI development?
There's also a lot of work being done on creating hybrid AI models that combine different AI techniques, for example, combining reinforcement learning, deep learning, and symbolic reasoning. It's about creating systems that can learn more broadly and flexibly, drawing on the strengths of different approaches.
So like a best of all worlds approach to AI.
You could say that. It's about integrating different methods to create AI that is more robust, adaptable, and ultimately more intelligent.
This is all incredibly exciting,
Yeah.
but it also brings up some big questions. What about the implications of AGI? If we create a machine that is as intelligent as a human or even more intelligent, what does that mean for humanity?
Those are questions that researchers, philosophers, and even science fiction writers have been grappling with for a long time. And there are questions that we as a society need to be asking ourselves as we continue to develop AI.
Right. It's not just about the technology itself, but about how we use it and the impact it could have on our world.
Exactly. AGI has the potential to revolutionize our world in countless ways, but it also presents some potential challenges. It's crucial that we approach its development thoughtfully and responsibly.
Okay. Deep breath. I'm ready to dive into those potential impacts and implications. Let's talk about what AGI could mean for society, for the economy, and for the future of humanity. So AGI, it has the potential to revolutionize pretty much everything, right?
Yeah.
But it also comes with some potential downsides and challenges.
Hmm.
We have to be careful about how we develop it, right?
Exactly. It's not just about the technology itself. It's about how we use it and the impact it could have on our world. One of those big questions, the one that always comes up in sci-fi, is about the singularity.
Right, the singularity, that moment when AI surpasses human intelligence and the consequences are almost impossible to predict. It's an idea that's both fascinated and kind of scared thinkers for decades now.
Yeah, I mean, it really is a powerful thought experiment. It can help us consider where AI might be going and, what our role is in shaping that.
So what exactly is the singularity?
Yeah.
And why is it such a big concept?
The singularity is usually described as the point where AI can basically improve itself. It's like once AI gets smart enough, it can design and improve on itself faster and faster.
So it's not just about us creating smarter AI, but about AI creating even smarter AI, leading to an intelligence explosion.
Exactly. And that's what makes the singularity so fascinating and for some people a little bit scary. The changes it could bring are almost impossible for us to even imagine.
It's kind of exhilarating and daunting at the same time.
Yeah.
Imagine the possibilities, solutions to global problems, crazy technological leaps, maybe even living way longer than we do now.
Right. Those are some of the more optimistic scenarios. But there are definitely concerns too. What if this superintelligence decides it wants something totally different from what we want? What if we lose control?
Yeah, it's like standing on the edge of this unknown territory full of amazing possibilities, but also knowing there's risk involved.
Exactly. And that's why we need to be having these conversations now while AI is still relatively young. We need to think about ethics, potential risks, and how we can make sure AI stays beneficial to humanity.
It reminds us that just making powerful technology isn't enough. We need to be thinking about its purpose and making sure we're building it with our values and safety in mind.
Absolutely. It's not just a tech challenge, it's a social and philosophical one too. We need to consider what kind of future we want and where AI fits into that.
So what can we do to prepare for the singularity, even if we don't know for sure if or when it will happen?
One thing is to help people understand AI better. The more we all know about how it works, the better we can talk about it and make good choices about how it's developed.
So it's about demystifying AI and making it something everyone can understand and engage with.
Right. We also need to really focus on AI safety research. That means developing strong safeguards, control mechanisms, and ethical guidelines to make sure AI stays helpful to humanity.
Creating AI that's not just intelligent, but also aligned with our values and goals.
Exactly. And that takes collaboration across a lot of different fields, like computer science engineering, philosophy, ethics, social sciences.
It's a reminder that we have a say in what the future of AI looks like. The choices we make today will really impact the world of tomorrow.
Well said. I think that wraps up our deep dive into the world of AI. We've covered so much from the different types of AI to that mind-blowing concept of the singularity.
It's been a fascinating journey for sure. We talked about how AI learns the possibilities of AGI and the big questions we need to be asking as this technology keeps advancing.
AI is changing so fast, and it's crucial that we stay informed, engaged, and curious about where it's going and how it's impacting our world.
So as you go about your day, think about all the ways you encounter AI. And remember, keep asking questions, stay curious, and be part of the conversation that's shaping the future of this incredible technology.
Until next time on the deep dive, keep exploring, keep learning, and keep those minds open to the amazing possibilities out there.